Union, you could well risk death for inventing a rational theory of prices. So this was really a great man. Here, in fact, his theory, now called linear programming, occurs in a number of problems, like the one I put here, which are solved daily by many industries. This is taken from a tutorial that you get on the web of all these linear programming problems, which all fall in the range of the Kantorovich technique. And it's about linear programming is whenever it happens that you have to optimize some quantity which is proportional to each amount of the unknown. And it's done very well nowadays by a number of computer tools. So you see here the power of the abstraction, which allows you to solve a number of problems at the same time once you identify the right formalism. So these are three great men. Each of them destroyed a great war. Kantorovich and his theory of optimal transport, optimal allocation, Riemann and his theory of non-Euclidean geometry, fat or skinny triangles, and Boltzmann with his entropy and formula. Now, sometimes progress is obtained by destroying a wall against adversity, against the unknown. Sometimes it's obtained by destroying an internal wall, something that separates some fields. And this is the case of what I'm presenting here today. So a wall which we destroy together with some collaborators between these three fields, recognizing a hidden unity behind them and a link that was unexpected, completely unexpected for us also. This was made a team. Like all many scientists, I'm just part of the team. If you look, just another brick in the wall, the great wall of science. And in particular, made with my German collaborator Felix Otto, at the time in Santa Barbara, and my American collaborator John Lott. So one fine day, I was in this ugly building, my department in Berkeley, on the beautiful campus, and John Lott knocked at my door. Hello, Professor Villani. I read your paper with Felix, and I'd like to do some great work together about Riemannian geometry and your work on optimal transport. I was very surprised. What is this going to do? And we did a long collaboration and solved this problem, and found this link that John felt there was as a consequence of our work with Felix Otto. Let me, in just one slide, one thought experiment, as I'm trying to have said, summarize this link. Let's call it the lazy gas experiment, and you will recognize the three basic ingredients of the three theories I presented to you. It's a new way to conceive positive curvature. But now it's not about the shape of triangles, but it is equivalent. But it is set in terms of statistical theory, the way you would explain the ideas of Riemann to Boltzmann if he was still alive, or to his ghost. Now, this is the experiment. You start from a gas. You see here on the top left, there is at equal zero, a certain density of gas. In now some region of high density, low density, and you see out that the gas has to be in another configuration at times equal 1. Say 1 minute later, you impose this on the gas. And the gas will obey you, and all the particles of the gas, or the molecules, will be redistributed to occupy positions at time 1 in such a way that the new density is achieved. But the gas obeys you, but he's lazy. He doesn't want to spend too much energy. So he will do this process of relocating the mass in the most economical way, as in the world of Kantorovich. And while the gas is doing this, at each moment of time, you measure its entropy, its disorder, in the sense of Boltzmann, using the formula set by Boltzmann about the entropy, S is minus typical rule of rho. Whatever this means, you compute this entropy, and if the curve is like this, always concave, always above the line, then you know you live in a positively curved way, in the sense of Riemann. So in this way, the three concepts are linked in an unexpected way. Will this have practical applications? Who knows? Maybe 100 years from now, maybe a few years, maybe some computer program, who knows? In a way, this is the end of my talk, but this was the beginning of the story for me. Based on that in particular, I wrote a 1,000-page book of optimal transport called and You, which was quite a hit in the community and inspired many further research and inspiration also from the frequentation of these dead people. And this also you may say, you see, as soon as you make connections between different fields, all the knowledge you accumulated here, you can recycle there. All of a sudden, you're richer in terms of knowledge. So for the moment, I will just be happy to say that I'm happy as a scientist who just discovered a new way to look at the world, a new enrichment in terms of knowledge. Thank you very much.